Okay, a new piece of algebra to show you today, finding the linking equations to circles and showing how we can graph those. So I think this is the first time we've seen an equation where x and y both have a power. So working out what shape that will draw would be tricky, except it's in the title, unfortunately. So there are two ways to think about this and two ways to go about it. One is just to try your best to find some values in here that plot coordinates over here that fit this formula. So if x is 1 and y is 2, does that make this? No, so that's not right. If x is nothing and y is 25, does that work? Perhaps, and we could plot it if it does. But that's not very satisfying. It doesn't give you much clue as to why it works. So whilst we will do some number work, the main thing is to understand what this actually is and why it should end up being obvious what shape it draws. There's another formula you've seen that has two square things added together. And you did that a few years ago, and it's Pythagoras' theorem. When you had the two square things added together, they equaled a third square thing. So it'd be super convenient if I picked a number that has a nice square root. Oh look, that's 25 squared. So that means that this equation is actually x squared plus y squared is 25 squared. Now in Pythagoras' theorem, 25 squared is 625. I've not changed what this is worth, I've just changed how it's written to make it clearer. So, in Pythagoras' theorem, the values we were squaring were lengths, were distances on a triangle with a right angle. Now conveniently, on a coordinate grid, the standard one anyway, x and y are already at right angles. So we already have some link to a right angled triangle. So if I draw a right angled triangle this way up to start with, to keep it simple, that distance there is an x-type distance. And that distance there is a y-type distance. Because that's across and that's vertical. That's the way x and y point on our normal Cartesian grid. So that means this must be a 25-type distance. Now this x could be very, very small. Could be a very narrow triangle, and y could be very, very tall. But that would still be 25. X could be very, very, very big, and y could be very small. But that would still be 25. So we're looking at lots and lots of different triangles at the moment, which all have a hypotenuse of 25. We've still not got a coordinate though, so we need to put this on a coordinate system. So if I put a coordinate grid down here, and I put a point here, this coordinate will have an x value and a y value. And that means that this distance will be x, and this distance will be y. And we can now see the right angled triangle we had before is linked to the origin. Okay, so this 25 becomes a distance from the origin. Now you know exactly one 2D shape that has points that are the same distance from an origin. So if I just put these three on, so we had that triangle, this very tall thin triangle, these are all the same distance from the origin. And in fact, I could have done it with a negative x value. There's a point over here that has the same distance from the origin. And there's a point over here that's the same distance from the origin. And in fact, if I do all these points, hopefully you're seeing that this will be, all these points lie on a circle, which I've drawn really accurately using all my superb skills. So a circle here will have a radius of 25. So this equation here is the equation for a circle with a radius of 25, not 625, 25. Now if I very quickly get some values for you and show you this work, I've chosen a particularly convenient one. So I'll talk through some simple values and I'll rush through some others. So because that's a square number, we could have 0 squared plus 25 squared. And once we have one pair like this, there's lots of things we can do to it. I could change this 25 to be negative 25, because as you know, when you square things, they become positive. I could also swap which one is x and which one is y, and it would still come out to be the same total. So those all equal 25 squared, which means these coordinates 0, 25, 0, negative 25, 25, 0 and negative 25, 0 all lie on this curve over here, which I hope is on screen, good. Now there actually are other values as well. I've chosen a particularly convenient triangle. As it happens, we've multiplied this by 5, so we want 15 squared plus 20 squared is also 625, and we can do the same positive, negative, swapping x and y around and get all the combinations out of that. So we could have 15 and negative 20, we could have negative 15 and positive 20, and we could have negative 15 and negative 20 all squared where appropriate, and those are all equal to 625. And I can do the x and y swap as well. I'll do that quicker under the fast forward section. And there's also another one. I've also chosen it so we get 7 squared and 24 squared. And again we can do negatives and swapping and flipping. So hopefully with a swipe of the hand we'll get to fast forward and out again. So, I haven't written all the additions and squarings here, but that list of coordinates are all the integer values that fit on this equation here. And I chose this equation because it had lots of integer values. It's a small one that has lots of solutions. So if I make some attempt to do those accurately, you'll see what's going on. So 0 to 25 will be 25 straight up, 0 negative 25 and 25 straight down. That's 25 right, and that's 25 left. So that gets you already, we're seeing some 4 quadrant symmetry going on. Even if we don't understand why, we've got values that show we're getting all the way around. So 1520 is somewhere like there, and then 2015 is somewhere there, and then these will be symmetrical when we start throwing the negatives in. Unfortunately, I'm out of squared paper, which is why I'm doing this online. So, we've done all the 20 and 15s, that's those 8. Then 724 will be even narrower and even taller, and be something like that, which means I've got some slight scale issues, but you get the idea. So, we now have these points arranged roughly in a circle based on my terrible accuracy. But we could work out irrational values in here to fill this in. So, generally speaking, an equation like this is a circle centered at the origin with the radius here. So something like x squared plus y squared is 49 is a circle centered at 0, 0 with a radius of 7. X squared plus y squared equals 3 squared. They've written it differently, but it has a radius of 3, centered at 0, 0. And it might not be a nice pleasant number. X squared plus y squared equals 10. We'll have a radius simply of root 10, which is 3 and a bit. So, that is the equation of a circle. All you've got to do at the moment is just recognise that it exists and be able to identify the equation. So do have fun with that, and we'll do some problems with it next time. Goodbye.